Apparently we lost audio for the first 5 minutes. Oh, yeah. All right, so the goals of actually redoing this are, one, the user interface. It's clunky and pretty much unusable. Maintainability. It is written in a combination of C++ and Perl, and this is an absolute pain. There's side effects all over the place, and it's very difficult to add data. Extensibility. It's also very difficult to add additional features. Basically, make everything better. Considering what we're coming from, though, it's not that lofty of a goal. It's like having an 8-foot limbo. So, architecture that we came up with, we have some base data, which is those 150-year time series. We apply aggregation and averaging, subsetting, preparation of that, index that data in PostgreSQL. Both of these, the base netcdf 3-dimensional data and the Postgres feed both NCWMS. We have a custom version of NCWMS running that sources its config from the database, and the backend in Python. That sources, it sends the data over, it can send it over OpenDAP, or we've designed a REST API as well, and gets the metadata from Postgres. So have we been successful? One of the main aspects was to decrease our technical debt, and we have dramatically. The regional analysis tool was 10,000 lines of C++ on the back end. We've taken that down to 1,000 of Python. Most of our actual API handlers are anywhere from 20 to 50 lines using NumPy and GDAL. The data preparation, we now use all CF metadata standards as climate and forecast. So there's netcdf itself is a self-describing format that allows you to describe what's in the file before you actually get to the data. So now we leverage that to index the data. And the front end was previously about 10,000 lines of this is Perl, being served through mod Perl. And we made it much more capable, much more of the processes are now actually ran on the front end, on the client rather than the server. And we still have a reduced code base. So that also is a big gain right there. What do we get? Now we were taking some cues from our previous design and seeing what works. See, we have a reduced number of selectors. We can select our variable and our emission scenario. Who here is familiar with climate data? I know there's some climate folks around. One. Okay, a couple. So your emission scenarios are kind of like what happens when we emit carbon. There's RCP 8.5, which is business as usual. Let's just go willy-nilly and burn all the coal. RCP 2.6 is the if we implement the strictest standards with what has been agreed upon at international conferences, and RCP 4.5 is something that's maybe a middle ground, something that might actually happen. As we can see here, by default we're looking at the entire region. We're looking at frost-free days for RCP 8.5, and in Canada at least the frost-free days are decreasing. Sorry, the frost days are decreasing by 100. If we select a region, all of the UI elements update automatically. So now we're looking at an area in Northern Northwest Territories. We have some map controls. You can adjust the styling. Oops. You can import and export polygons. You can zoom into a region, and if you want to make a better map out of it, you can auto-scale the climate layer that you're actually looking at. We have a configurable backend where you can actually configure it with different data sets. So from the database, one of the members of that is ensemble, so we can define which data sets get populated in the front end by changing one configuration variable. From this, we can see we have different data. We have different representation of that, and this you'll see a climatological seasonal curve of the minimum monthly temperature. If we look at projected change for another model, we can see that there's an ensemble and 5 models being represented, and that is TXX, an extreme indice that is the maximum monthly temperature for that particular month, the maximum of the maximums averaged over a 30-year climatological period. So how do we do that? Again, back to the architecture. We have netcdf base data. This is just stored in a POSIX file system, which is a massive technological challenge if we're dealing with We have about 200 and something terabytes of climate data right now, and we just can't serve that up. On our data portal, we have live about 30 terabytes. But for actual real-time analysis, that's just too much data for us to scan through in a POSIX file system. So we're still looking for solutions for that. The backend API, it's very lightweight, I mean less than 1,000 lines of actual code. And that's running through all Python with a Flask WSGI backend. Most of the actual computation is offloaded to NumPy and GDAL. The backend database itself, where we store all the statistics and do all the configuration for the front end, that is pluggable. We currently have it only tested with PostgreSQL and SQLite. And the asterisk is that we have our custom NCWS instance, which sources from Postgres. We have not tested that with different database backends. What I really want to talk about more is the front-end implementation. And this is kind of all the much more interesting technology that's very right on the edge. Everything changes far too quick to keep a hold of. One of that is React. And does anyone use React currently? Okay, and in production instances? Less hands. It's, for those that don't use React, it's kind of a way of getting web components now, more or less. You can have stateful or stateless components. And the idea with that is data-driven updates. So you have a virtual DOM where all your updates can happen, and then once you look at the difference between what the user is actually seeing and the new virtual DOM based upon your data, the differences are applied in browser, and it's really quick. So you kind of build your components out in a stack like this, where this is a search box, so it probably maintains a search in the state of that component, and that actually affects what other items will be shown in the list if they match that criteria or not, and that can be done on a per component basis. We also use Webpack. There are many other module loaders for loading all your JavaScript, CSS, and resources together. AMD is one of them, Require.js. I have had serious problems with pretty much every other one of them. Not to say I haven't had problems with Webpack. But it can take all of your module dependencies, be it JavaScript, CSS, Jade templates, Coffee, apply different loaders to them, and compile them all together into a bundle. Basically a bundle that contains all of those dependencies dynamically packed in together and deduplicated. It's much more easy. It basically gives you an import. It gives you the capability to import other modules in JavaScript. With this, we're actually going to demo and cross our fingers. So, actually, let's go back here. What this is, who's developed a node before and is familiar with NPM, NVM, and all that? All right, so this will look moderately familiar for those folks. Basically, we're starting a new project, starting a new node project, and installing some dependencies and saving them as development dependencies in this case. Now, I've done a little repo that I actually did just check out one. So, what is this? So let's forget about that first commit there. Most of your standard package.json, which is generated, most of it, by npm init, your basic description. The only things that I've added to this are the copy and build. There's a couple of commands, just kind of shortcut the build process. And the development dependencies, these are added automatically when you install any module and actually save them with the -D for development. React comes into play when we actually create a component. Now, this is a very basic component here. All it does is return a div with some random text in it, because I could not think of anything better. We have the HTML template that this goes into. There are ways to improve this. If you're familiar with Webpack, you'll know you can generate this dynamically as well. But for this purpose, we aren't going to be doing that. Basically, what will happen is the app will look for this ID and replace this div with all of what React generates. How does it do that? Well, our entry point for the app is right here. We look for the element and replace it with our app, which is that main component right there. Most of the difficult stuff comes right here with actually configuring Webpack. There are lots of examples, lots of tutorials out there, but something tends to go wrong. This is kind of just filler. You're importing your modules, you're defining your application dir and your build directories. A port, oh, that actually shouldn't have been in there yet, but anyways, our entry point is our index.js, so what we had just right there. And what Webpack will do is go in, look at index.js, see what the imports are, and dynamically go and resolve those dependencies and bring them into the bundle. I've only defined one loader here, and that's if it finds a JS or JSX file, send this through the Babel loader, which in this case is what enables us to use ES6 syntax or ES 2015. And there was a configuration right at the very top that actually configured Babel. So we're using, again, that ES 2015 preset, and we're letting it be aware that it needs to translate React syntax into its bundle as well. So what does this actually do? Let's build it. And it will output our index into the dist folder as we've specified in the Webpack config. Here we go. That's all it was. That's all the text we put in there. And that's not very interesting. You need to build it every single time, and then you need to open your index.html. You need to refresh and do all that. There's a better way. And that would be with Webpack Dev Server and React Hot Loader. What this Webpack Dev Server will do is monitor the changes within your source and automatically refresh and rebuild your bundle when it detects those changes. And React Hot Loader just simply makes this a bit more efficient by only replacing the components that have changed. So let's take a look. We define another command in package.json. We brought in a couple more of those dependencies. That's been done automatically with the npm install. We've also defined a couple entry points, more entry points. So instead of just entering at our index.js, these create additional entry points, one for Webpack, where it can source its bundle files from, and another one to enable hot reloading. And I'll demonstrate that in just a little bit here. We do have to add on to the loader chain that we need to pipe our files through React Hot before sending them to Babel Loader. And again, you have to enable the Hot module plugin. This is something just to, if there are errors, abort the build. And this is the configuration for Webpack Dev Server. This is all pretty standard. You can get this by reading the reference documentation or looking at examples out there. Let's go now. So let's use our new command. npm start. And we're now on localhost 3000. And if we actually, let's not use Emacs because we have this. So let's make a quick edit. That may have been a better title. We'll save it. And we can see that it is updated automatically in our browser. Really useful for any development work. This is pretty basic for what we can do with React and Webpack. It's kind of just setting up a project and setting up some of the requirements along the way. So what's next? One of the big powers of React and bundling this Webpack and NPM is you can bring in other React modules that you do not have to code. One of those is React Bootstrap. Ooh. Let's just stop that first. Actually. So looking at our differences now, we can see we brought in React Bootstrap, and all we've done is applied a page header element to what we used to have for H1 and H3. We've also brought in the Bootstrap styles from their CDN. Now this is Again, something that's a little bit, I'm not going to be covering in this, but you can also inject the CSS styling into your React, into your bundle, and have that exported as well. And you would not necessarily have to do things this way. There are a number of paths. So let's take a look at what we've got. So we can see our text been replaced with the Bootstrap elements. And again, we did not have to create any of that. This is a very basic example of any of the Bootstrap components you can add into React. There are so many more. Everyone's developing. There's a React wrapper for Leaflet. There's React wrappers for tables. There's React wrappers for pretty much every UI element you'd like to create already. Again, this is Geospatial. Let's get into Geospatial. So all we're doing is install Leaflet and take a look at the differences that we've made here. So Leaflet is installed. All we're doing is changing our main component to include the web map, which is where most of the logic happens. So there's going to be a lot going on here, and this is going to get a lot larger for people who have not been exposed to React Webpack before, but try to bear with me. And if you have any burning questions, just shout them out. We do have to find a style because you need to have a height on any Leaflet element. There is serious struggles with React, with works in a virtual DOM, and Leaflet, which needs an actual DOM. So what we need to do for this is simply create a reference to that DOM element, and then link into one of the lifecycle methods of React, so a component did mount, and then you know that reference and that DOM point actually exists. At that point, you can create a map and set your view. We also need to bring in Leaflet styles, because that's a game. Let's start it up. We have a Leaflet map in React. And pretty basic. I mean, this is not too difficult. You can do this in HTML and CSS as well. The real power comes with adding additional NPM resources. I'll just go adding Leaflet draw here quick before we get to that. Actually, no, in the interest of time, I'm going to skip that. We're going to go right on to the next one. Let's pretend we configured Leaflet draw, and let's actually look at some interesting geospatial libraries we can integrate into the React Webpack framework. So the changes we've made here are installing libraries. Again, NPM does that for us. We defined a geo exporter component. So this is an additional component. We're sourcing in some Bootstrap libraries. We're sourcing in a geographic translation kind of module that I'll show in a second. We have a function that we can call on click for any of the Bootstrap elements. The map has to have some style changes just to accommodate the additional elements. We're now going to, with Leaflet draw, we actually maintained an area in the state as well. And just for simplicity's sake, we're going to clear all the map features before we actually add any new. So we only deal with one feature at a time. When our feature is created in the map, we turn it to GeoJSON. We add some properties to the source because the shapefile does not like to have empty attribute tables. And then we set it to the state of the map component. That is then passed into the geo exporter as a property. So whenever this state element updates, when I'll show in a second here too, when you draw a polygon on the map, that is automatically re-injected into, it'll just reference from the geo exporter. And the geo exporter, if we go back up to it here, we can see it has the properties and it expects an object. So it passes that into the export polygon function. Let's start that up. Oh, it's not. So again, I skipped a step with adding Geospatial Leaflet edit rather. Let's just make a polygon around Raleigh here where we are. And we can now export this as any number of formats. This is all happening locally in the browser using Node modules, or NPM modules, filesaver.js in particular, to allow you to save files with zero involvement from the server. That's being converted as I hit the button into the various formats that we can. And there we are. So that's a very basic kind of introduction of using the power of NPM within the front end of a geospatial web app. There's a lot more you can do, and it can get complex moderately quickly if you're including lots of what are traditionally server-side Node.js modules into your browser. There are obviously some caveats. So what's next? This is something I talked about. Your CSS, I had some inline styles there. That's really difficult to maintain. I'd rather just actually have things done in CSS. This is something in our project that I have implemented, but I didn't get time to actually go into the demo. Font and media loading. Your CSS can also dynamically require the images, fonts, and any other resources you need. These you can also then configure to be generated as a data URI or actually source those as external files. It'd also be nice to have a DevTools source map. The issue that I talked about earlier about actually maintaining your styles in your CSS and an HTML template, that can be done a lot better. There is a Webpack, I think it's Webpack HTML loader where you can define a template and then have that HTML entry point generated dynamically based upon whatever resources you're bringing in. Deploy config. This is something I didn't touch on at all. You can send this bundle moderately easily through Uglify and Dedupe with just a couple of plugins. You configure an environment variable, you change your pathway and your configuration of Webpack, and then Bob's your uncle. Redux and Flux. What you saw right there, when I was saving the polygon in the state of the map, that's not necessarily ideal. What if I wanted to access that resource from a different component that was outside of the scope of the map? You really do need, I strongly recommend investing the time using Redux or Flux or some sort of global event framework. It will be worth your time later on. And Docker, we deploy or are beginning to deploy everything with Docker. Everything, our WMS servers, our front ends, our back end, our Python microservices. And the reason why is because it's really, really easy. With this one Docker command, I will spin up an entire, well, I hope I will spin up an entire backend for our app that I was showing the slides for earlier. And if we go up, this is actually, this is sourcing it's configuring the database that's already set up within the backend. It can query the data, and I have about just 10 gigabytes of local data for our very reduced model set on this laptop. And just really spend time with Docker if you haven't looked at it yet. It's going to be really valuable for automatically scaling anything within the cloud. Challenges we have experienced, and there will be many. We're stuck with netcdf files for now and POSIX file system access. That's a massive challenge for us. There are apparently major developments within GeoTools and GeoServer 2.8 that allow actual multi-dimensional netcdf support within GeoServer and GeoTools, and we're looking to scale out, basically. We're still limited by some of our data portals copying over 20 terabytes of data to a unified storage before actually we'll be able to spin up a backend. That's not ideal. Rapid Node.js development. Lots of this, I've only been using Node since last spring, really, so over a year. I'm by no means a front-end expert, and everything changes so fast. When I first started, we were using Babel 5 because the ES 2015 hadn't been fully ratified yet. And actually migrating from Babel 5 to Babel 6 has just been an absolute massive pain because, well, it just is. It's mainly breaking all my testing libraries. I was working with Jest before, but probably recommend using Karma and Mocha or some other test runner like that. You really do have to spend a lot of time keeping up with all the changes, keeping up with all your version updates, or you will fall behind and you will get in bugs. DOM libraries with React. Again, this is where we looked at with Leaflet. Leaflet expects a full DOM. React doesn't actually supply that. And you can get around that with tying into lifecycle methods, with referencing your DOM nodes, or creating references to your DOM nodes. And that's a workable problem. Projections. We work in WGS 84 on any normal kind of Canada-wide climate model, and in BC climate models, we work in EPSG 3005. Making base maps that work in any projection that's not Google is a massive pain. Not only did they want to make the world flat, they wanted to make it square. It just doesn't, it's not easy for any sort of coverage or raster data. But it's doable. There are some reprojection libraries with Leaflet, and our backend WMS, NCWMS, does support reprojection, and we've managed. Lastly, thank you. I'd like to open the floor to any questions. Yeah.
So you said that like Leaflet needs a DOM, and React doesn't really give a DOM.
Mm-hmm.
Do you ever consider just kind of dropping React because a lot of the data is really being pushed in the map, and the map is really doing a lot of heavy lifting there? You really need React for doing all your UI.
We find with, sorry, the question was, do you really need to have Leaflet within React, or do you want to just split that out? I guess why? We've found that most of our Leaflet is really just geared towards a display. We're not doing any massive processing, so we can just, within React, we can set as a property the layer ID, so the rest of the UI can be responsible for updating the Leaflet layer. We can hook into the redraw functions and change things that way. It has enabled us. It's also easier to get things out of the map, I guess what I'm saying, with exporting and importing geographic areas and just making this available to different parts of the app without relying on any global structures. It's an option. Our other products, we haven't used React, and it's been acceptable. But we found the benefit of all the other UI elements and the ease of development that gives us has been worth it. There also is, someone has actually developed a Leaflet React wrapper for Leaflet, and I haven't used it, but it's really just setting all the Leaflet configuration items as React properties. I don't know how that works.
I'll do another one.
All right.
So how do you deal with JavaScript burnout? It sounds like it's kind of constantly changing. How are you every day you get in and if something's changed, how do you keep up with that?
We kind of, when you install something by default with NPM, it pegs it to a particular version. So we kind of keep them pegged to those particular versions for a period of time before we are required to upgrade them. That's basically how it goes. Most of the changes that we've encountered that have been breaking for us have been React updates, where various other libraries that we want to use require updated React, but React then has certain features deprecated with newer versions, and that has just kind of been a game of cat and mouse. Does that answer your question? Any more? Yeah.
So are you mostly using refs to deal with Leaflet and React?
The question was, are we mostly using refs to deal with Leaflet and React? I think we're only using refs to work with Leaflet and some of our graphing libraries because they're the only ones that expect a DOM. Does that answer your question?
Yeah, I guess when I've messed with it quite a bit, and I just wanted to hear about struggles maybe with some of the patterns of React now. We're talking about splitting out the logic into containers.
Yeah, so
Stateless, and then you can't use
The question was, how do you deal with React is now kind of going towards stateless and stateful components. Stateless components are really lightweight, and actually I did not demonstrate them. They actually tie in very well with Redux and other global event frameworks where you have kind of your containers, which have your logic, your AJAX calls, your any sort of like application function, and then your actual components, which are basically all dumb display UI elements. You pipe them some data, they update based upon the changed data. So working with stateless components and DOM refs, that's not actually something I've gotten into yet. Might be useful to talk afterwards. All right, well, if no more questions, we'll close the floor. Thank you so much.